Hello everybody, and again I am going to tell you some problems on group theory. Okay, perhaps I think the problems and theorems which I have given in my previous videos, perhaps you are enjoying, and I hope I am satisfying each and every video. 100% I will try to satisfy you. Okay, and I will try to give each and every problem. Okay, I will try to give you. Okay, so there may be some gaps. That means every day I cannot give because I am giving some videos on class 11, class 12 and on +3 first year, +3 second year, and also for B.Tech and also for competitives. That is why there may be some gaps. Okay, so please have some patience. Okay. See here, this problem is very important. If G is a group in which a b to the power n is equal to n into b to the power n for 3 consecutive integers n, this condition is satisfied for 3 consecutive integers. That means n plus 1 and n plus 2. And what are A and B? A and B are any elements of the group G. Then you have to prove G is abelian. You have to prove G is abelian. That means G satisfies the commutative axiom. Okay. So let the 3 consecutive integers be. Let the 3 consecutive integers be n plus 1, n plus 2. So therefore, and it is given there a b to the power n is equal to a to the power n into b to the power n, and a b to the power n plus 1 will be equal to a to the power n plus 1 into b to the power n plus 1, and again a b to the power n plus 2 is equal to a to the power n plus 2 into b to the power n plus 2. So what is the trick actually by which you can prove very easily without remembering how to do it very rapidly and thoroughly without any hesitation? I'll tell you the trick. The trick is that if you want to write a to the power 5, so it should be written as a to the power 4 into a. And if you want to write a to the power 6, so write it a to the power 5 into a. The single a should be written on the right hand side, not on the left hand side. That is the trick. That means if you want to write a to the power n, it will be a to the power n minus 1 into a. If you write a to the power n plus 1, it should be a to the power n into a. Like this you should split. Okay, so simply remember this thing, way how to split. So that we are applying, we should apply this trick here. And then now let us proceed here. Now a b to the power n plus 2, it is a to the power n plus 2 into b to the power n plus 2. Simply split a b to the power n plus 1 into a b. Clear? I have told you how to split. Now split this one, a to the power n plus 1 into a into b to the power n plus 1 into b. Okay, now let us see. And a b to the n plus 1, already it is given a to the n plus 1 into b to the n plus 1. So right here, a to the n plus 1 into b to the n plus 1 into a into b. And I am applying the associative property. Okay, here also apply the associative property. A to the n plus 1 into a into b to the n plus 1 into b. Okay, so apply the left cancellation law. So a to the n plus 1 cancel out from both the sides, and applying the right cancellation law, so b will cancel out. Okay, so now the remaining part is b to the n plus 1 into a is equal to a into b to the n plus 1. Okay, so how to make this one a to the power n plus 1, so that this will become ab to the power n plus 1. So you should multiply a to the power n. Okay. So a to the power n into b to the power n plus 1 into a is equal to a to the power n into a into b to the power n plus 1. Okay. Now this one a to the power n into b to the power n into b into a. I am writing this one and this one, applying the associative property. Okay. Now this one is equal to a to the power n into a, and this one I can write I am combining a to the power n into a into b to the power n plus 1. So this will be ab to the power n into ba, and this will become, tell me, who can tell me? A to the n into a, it will be a to the n plus 1 into b to the n plus 1, and this will become ab to the power n into ba is equal to, and a to the n plus 1 into b to the n plus 1 is ab to the n plus 1, so it will be ab to the power n plus 1. Clear? Now I am writing here, now ab to the power n into ba is equal to, as I have told you how to split this one, so ab to the power n into ab. So simply cancel out from both the sides. After applying the left cancellation law, these two cancel out and remain ba is equal to ab, which is the commutative law. That means G is abelian. Clear? So this is the proof. Only I have applied the trick which I have told you from the very beginning. Okay. So I hope you have understood. And let us see another problem. Let G be a group and A belongs to G. That means A is any element of the group G, and E is the identity element. Such that A into A is equal to A. A into A is equal to A. Now prove that A is equal to E. So you want to prove A is equal to E. So how to do this one? How to prove A is equal to E? So let us see the proof. Given, what is the given condition? Given A into A is equal to A. So this is equation 1. Okay. Now since E is the identity element of G, so for all A belongs to G, A into E is equal to A. Clear? So therefore from equation 1 and 2 we get this one equal to A, this one equal to A, so A into A is equal to A into E. So applying left cancellation, so simply apply the left cancellation, cut out these two, so we get A is equal to E, which is our requirement. That's it. Clear? So actually you should know the definitions and conditions so that you can do the problems very, very easily. Okay. So if you will try, then you can do everything. Seriously. Simply remember the definition. I have told you the definition of group. Have you remembered the definition or not? Again I am repeating. If a non-empty set group, non-empty set G is said to be a group under the binary operation dot if it satisfies the four axioms: closure axiom, associative, identity and inverse. And what is closure axiom? For all A, B belongs to G, A dot B belongs to G. And associative axiom, for all A, B, C belongs to G, A dot B dot C, A dot B dot C is equal to A dot B dot C. Okay. And what is the identity property? See here, first of all you should write identity, then inverse. After knowing the identity element, you can find out the inverse. Okay. So, for all A belongs to G or for every A belongs to G, there exists E belongs to G. That identity should be an element of G, such that A dot E is equal to E dot A is equal to A. That means, if you operate E to any element of G, there will be no change in the element of G. So, inverse axiom. For every A belongs to G, there exists B belongs to G. B should be an element of G such that A dot B is equal to B dot A is equal to E. And in that case, B is said to be an inverse of A. Again, we can say A is inverse of B also. Okay. So, if it satisfies the four axioms, then the non-empty set G is said to be a group. And along with, if it satisfies the commutative axiom, then it is called an abelian group. Okay. So, I have told you, you should write the problems and theorems at least twice so that you can remember it. Don't read it simply just like history. This is not history, this is mathematics. Okay, so first see it and remember the definitions, then write it at least twice. Okay, thank you very much.